Welcome back to class. So we have treated the gradient, the equation of a straight line, the midpoint of a line. The last is the distance between 2 points. Now, please remember I said a straight line is the shortest distance between 2 points. So we're just talking about the distance between 2 points. We're not talking about the shortest distance. So it can be a long distance, it can be a short distance, but there is a formula for finding the distance between 2 points. So we have the gradient. I have erased that part from the board. We have the equation of a straight line. It's here. Remember this. You can save this. And then we have the midpoint of a line. This is the midpoint of the line. Remember, we're talking about line AB, and these are the coordinates of lines A and B. So we want to look at the distance between 2 points. There's a formula for it. So just look at the formula. Distance between 2 points. Let's go. Now the distance between 2 points is giving us AB equals to square root of y2 minus y1 squared plus x2 minus x1 all squared. Now, Mr. McCollings, how do we apply these equations you've given us? Quite simply, let's look at the questions. Let's take questions. 2014 question 32. It says, find the midpoint. So what I'm going to do is I'm going to write down all those formulas here so that when we try to solve a question, we just quickly make a reference, or make reference rather, to those formulas we have. So very quickly, I'll have them here. Then we'll solve the questions on this part of the board. So we have this as a mirror. So our mirror would be the formulas that I have written or I have taught you. So the first formula, if we go back, is the gradient. So remember the gradient, M is y2 minus y1 over x2 minus x1. The next is the equation of a straight line. Y equals to mx plus c. And the third one is the midpoint. Okay, let's call that midpoint. MIDPT for short. Half, you see this? x2 plus x1, comma half y2 plus y1. And then the last of all is the distance between 2 points, AB, the square root of y2 minus y1 all squared plus x2 minus x1 all squared. Now, so let's go to the first question. Find the midpoint of that. Can you see S and T? S has a coordinate minus 5, 4. T has coordinate minus 3, minus 2. So we want to find the midpoint. So we have S minus 5, 4, and T is minus 3, minus 2. What are we to find? Midpoint. So you see the formula? Midpoint. So if this is x1, okay, because the coordinates are x and y, so this will be what? y1. This is x2, this will be y2. So let's apply the formula. For the midpoint, we have half x2, which is minus 3, plus x1. Now remember that minus times minus is plus. Okay, we're going to put this somewhere. Minus times plus is minus, plus times plus is plus, and plus times minus is minus. If you're having a problem with this, it's quite simple. Just when the signs are equal, it's always positive. Minus minus equal, answer is positive. Plus plus equal, answer is positive. Otherwise, it is negative. Minus plus minus, plus minus minus. So when the signs are equal, the result is always positive. So that is that. So we have half minus 3, if you like to say this, plus x1 is minus 5. You see this? Comma half. y2 is minus 2 plus y1 is 4. So look up. What do we have here? I'm sorry. We have 2 brackets. Now this would give us half minus 3 minus times minus, sorry, plus times minus, I beg your pardon, is minus 5, half, minus 2 plus 4. Of course, if you owe 2 naira and then you have 4 naira given to you, you're going to pay your debt. You'll be left with 2 naira, so this is 2. So this would give us half comma minus 8 half 2. So what is the half of minus 8? Minus 4, and the half of 2 is 1. Minus 4, comma 1, the correct option or answer is option A, as you can see on the board. Now very quickly, the next one, the gradient of the line joining x, look at that, those two coordinates. We already have the gradient given. We're told to find the value of x. Very simple. Now remember, let me help you. Can you see the gradient? Formula is here. So let's have the lines. The coordinates of the line x, 4 and 1, 2. So if this is my x1, this will be what? y1. If this is my x2, this will be y2. What's the formula for gradient? M equals y2 minus y1 over x2 minus x1. Now what does M stand for if you remember? Gradient. And then we have the gradient given to us as half. So what that means is half equals y2 is 2 minus y1 is 4 over x2 is 1, x1 rather is x, 1 minus x. So this is half equals 2 minus 4 is minus 2, 4 is greater than 2 over 1 minus x. So what do we have here? When you have two fractions at the opposite sides opposite sides of an equal sign, the best way to solve that is cross multiplication, okay? So we have to cross multiply. So when we cross multiply, I told you, always keep your unknown to the left hand side. So this is going to multiply this. So 1 times 1 minus x equals to 2 times minus 2. Now I'm going to tell you something after this question. When I'm done, let's bring this up because of we're going far down. Now 1 times everything there is 1 minus x equals 2 times minus 2 is minus 4. So we have, if we send this one over there, we have minus x equals to minus 4 minus 1. Why? This is plus 1 here, it comes over here to be minus 1. So this is minus x is minus 5. If we divide both sides by minus 1, okay, this will cancel and x equals to 5. So the correct answer there is option C. Now, I said I want to tell you something. JAMB questions are multiple choice questions, as you can see. So nobody cares about how wonderful your steps are. If you can skip steps and still be on course, it's advisable. So don't be so meticulous, taking your time solving because you don't have the luxury of the time. So please take note of that. I could have skipped 2 steps here, but because I am teaching you, that's why I didn't skip the steps. So if you understand that you can skip steps, please do, so that you can save time. So we have the answer there. The correct answer is 5, which is option C. Now, I have 2 more questions to solve. Now, I have to solve these questions because we've not treated these questions. There are still about 2 of these formulas we've not used. So I'm going to treat them and then we'll move to the next topic. Look at this. It says, find the equation of a line which passes through the point. Now here, equation of a line. So there's one last one here, equation of a line. If you remember when I taught you that. So we have the point. What are the coordinates of the point given? The coordinates are 1, -1 and 3, 2. So this is x1, this will be y1. If this is x2, this will be y2. We're told to find the equation of the line, the equation of the line which passes through those points. Fine, what is the equation of a line? Can you see this? Y equals to mx plus c. Wow, so what do? We need to find the gradient of this line. How do we find the gradient? Remember, m is y2 minus y1 over x2 minus x1. Please pay a rapt attention because this is a different kind of question. So listen to how we're going to solve the question. So y2 is 2 minus y1 is minus 1. Always learn to use brackets. It will help your work. Now x2 is 3 minus x1 is 1. So this is 2 plus 1. Minus times minus is plus over 3 minus 1. And 2 plus 1 is 3 3 minus 1 is 2. So this is the gradient. Now, if we put this into this equation, we're going to have y equals to 3 over 2 x plus c. How do we find c? Very simple. Go back to the coordinates given. Pick any one of these two coordinates and substitute the values for x and y into this equation. You will get the value of c. Because if you look closely, we have three variables. We have y, we have x, and we have c. So if I pick these coordinates, the value of y here is minus 1. So if I say this is minus 1 equals to 3 over 2, and this is 1, x is 1 there, plus c. Now this will give me minus 1 equals this times 1 is 3 over 2. So 3 over 2 plus c. So what is c? c is minus 1. Take this big thing out of here. Minus 3 over 2. So if I do LCM, where you're dealing with fractions, remember LCM, try to make everything fraction. The LCM of 2 and 1 is 2. How many 1 can you find in 2? 2. 2 times minus 1 is minus 2. 2 in 2 is 1. 1 times 3 is this. So C is minus 2 minus 3 is minus 5. Minus 5 over 2. Can you see this? So we go back to this equation and put this here. So if we do that, we're going to have, let me use this part of the board. We're going to have y equals to 3 over 2x plus minus 5 over 2. Now remember that plus times minus is what? Minus. So y equals to 3 over 2x minus 5 over 2. Now look at the options. Nothing looks like this. So what do? We simply multiply all through by the LCM. This is 2, this is 2. So the LCM is obviously 2. So if we multiply all through by 2, we're going to have 2 times y equals to 2 times 3x over 2 minus 2 times 5 over 2. So 2 can go in 2 once. The same thing here. This 2 will cancel. So this is 2y equals to 3x minus 5. Okay? Now go to the options. You find out that they moved everything to the other side. So this gives us 2y. Now look at this. Good. We can move this one over here. So leaving us with, there'll be 0 here. If we move this over here. 3x minus 2y minus 5. Now if 2 is equals to x, it means x is 2. So if 0 is this, it means this is also 0. So that will be 3x minus 2y minus 5 equals to 0. Now this is the answer to the question. So as you can see, we have 3x minus 2y minus 5 equals to 0. Now that is option D. That's the correct answer. Option D. So we are good to go. Now the last one is this. Now this question you have to be very careful. The distance between the point 4, 3 and the intersection of y, please forgive the typo error here. Intersection of y equals 2x plus 4 and y equals 7 minus x is what? Now take note, there are two equations here. How do we solve this question? Very simple. Now look up, follow me. That's 2018 number 23. Just follow me, you have an understanding. Now the first thing to do here is to find, listen, distance between 2 points. The question is to find the distance between 2 points. How do we find distance between 2 points? We need to get two different coordinates. We have only one coordinate. So how do we get the next coordinate? If you look very closely, we have two equations here. These equations should be solved simultaneously. Now that's taking you back to simultaneous equation. So we have y equals to 2x plus 4. That's the first equation, if you like. Equation 1. The second one is y equals to 7 minus x. We can call this equation 2. Now, you remember your methods. Elimination method, substitution method. graphical method. Okay, so I'm reminding someone now. So look at this. We don't need to do anything. There is no miracle here. All you just need to do is to subtract this equation from here. The reason is y here and y here, they have the same coefficient. The coefficient is 1. So if we subtract, this will give us 0 equals, now 2x minus x. If you like, you can rewrite this. You can rearrange it, but it's fine. 2x minus x. That is 2x plus x. That will give you 3x. And then 4 minus 7 is minus 3 because 7 is greater than 4. So look at this. Send 3 over here. That leaves us with 3x equals to 3. So x is, if we divide both sides by 3, x equals to 1. Now we have the value of x, we need to find y. So we substitute the value of x here. So let's take equation 2. Equation 2 says y equals to 7 minus x. So if we substitute the value of x here, we have y equals to 7 minus 1. And 7 minus 1 is 6. Therefore, we have a new coordinate. Remember, the coordinates are arranged this way, x, y. So the new coordinate is what? 1, 6. Now we can find the distance between the 2 points. That coordinate and this new coordinate. So what do we have? 4, 3 and 1, 6. These are the coordinates. So we go back to this. This is x1, y1, x2, y2. So if we have that, let's say the points are A, B. It's quite simple. You have a square root. y2, 6 minus y1, 3 squared, plus x2, 1 minus x1, 4 squared. So that leaves me with 6 minus 3 is 3 squared, plus 1 minus 4 is minus 3. So this is minus 3 squared. Okay, so this would be root 3 squared plus minus 3 squared is 9. 3 squared is 9. So 9 plus 9. How is minus 3 squared 9, Mr. McCollings? Minus 3 squared is simply minus 3 times minus 3. And minus times minus is plus. 3 times 3 is 9. So we have this. So this gives me the square root of 18. Now, in short form, the square root of 18 is simple. 18 is simply 9 times 2. So the square root of 18 is simply the square root of 9 times 2. And according to the law of surds, if you remember surd, this is root 9 times root 2. So root 9 is 3, and then root 2 is here. So 3 root 2 is the answer. Option B is the correct option. So this is the last question we'll solve under this part, coordinate geometry. The next is trigonometry. We still have like say 2 more topics, and we'll wrap it up from there. So this is your answer. Let's go to trigonometry. This is quite simple. This is taking you back to what you did in primary school, if you attended a very good primary school like mine. So you remember they taught you that. So let's go. We have trigonometry. The first thing we're talking about there is Pythagoras Theorem. I tell my students that Pythagoras was my friend, my late friend. I still miss that guy. Now, before he died, or before he passed, he gave us a theorem. How do we get the theorem? Please take note. For Pythagoras Theorem, you must use a right angle triangle. It doesn't work with any other kind of triangle. It only works with a right angle triangle. So for a right angle triangle, let's label the sides. Depending on where the angle is, if we have an angle here, this side is opposite the angle. So we call this opposite. This is where the angle is sitting on or lying on. So we call it adjacent. Obviously, this is the hypotenuse, which is always the longest side of the right angle triangle. So Pythagoras said that the square of the hypotenuse equals to the sum of the squares of the opposite and the adjacent sides. What that means is, if we make this C, this A, and this B, C squared is A squared plus B squared. That's Pythagoras. That's just a revision for you. The next is Pythagorean triple. Now let me explain what this means. Now look at this. If this is a triangle, a right angle triangle, and this is 3, this is 4, okay? The question is, what would this side be? According to Pythagoras, this side will simply be the sum of the squares, the square of this side, let's call this side x. So x squared would simply be 3 squared plus 4 squared. X squared is 3 squared is 9, 4 squared is 16, that is 25. So x would be the square root of what? 25. The square root of 25 is 5. Now look at this. What this means is that 3, 4, and 5 are called Pythagorean triple. So all 3 of them form the sides of a Pythagoras triangle, that is a right angle triangle that obeys Pythagoras theorem. So 3, 4, 5 are Pythagorean triple. Now let me give you another one. We have 5, 12, and 13. Now how do I know that? What is the square of 5? 25. The square of 12 is 144. If you add this together, you're going to get 169, which is the square of 13. So you see, 5, 12, and 13 are Pythagorean triple. I'll give you another one. 6, 8, and 10. The square of 6 is 36. The square of 8 is 64. If you add both of them, you're going to get 100. The square of 10 is 100. So you see, I've given you another one. So we have this one, Pythagorean triple. These are also Pythagorean triple. And then the third one is the Pythagorean triple. Now let's talk about special angles. Special angles. Now, in trigonometry, there are 5 or 4 special angles. We have 30 degrees, 45 degrees, 60 degrees, 90 degrees. Some people add 180, but then we're just going to do this. Okay, for the purpose of your level, 30, 45, 60, and 90 are called special angles. So very quickly, I'm not going to derive anything. I'll just tell you why they are called special angles. They are called special angles because, before then, we have what we call trigonometric ratios. Hey, can somebody remember this guy? Socatoire. Everybody remembers Socatoire. Now, Socatoire, what does Socatoire mean? If you have, it has to be a right angle triangle. Please take note of that. A right angle triangle, and then this is the angle. What Socatoire simply means is that sine stands for opposite over hypotenuse. Cosine stands for adjacent over hypotenuse, while tangent stands for opposite over adjacent. So this is Socatoire. Now we have this Socatoire. So we're going to talk about special angles, like I said. So I'll just give you quickly, just put it in mind. You can write it down somewhere and memorize it, please. Now, let's start with 30 degrees. 30 degrees. Sine 30 is 1 over 2. Cos 30 degrees is root 3 over 2. Can you see this? Now, how did we get this? Like I said, I don't want to derive. I'll just show you the triangle where we got this thing from. I'm not trying to derive anything. No, because there is no time for derivations. So if this is 60 degrees, 30 degrees, this is 90, of course. The sum of angles in a triangle is 180. So if this is 90, 90 plus 90 is 180. So if this is 2, this is 1, this is square root of 3. You can do that. You can check that yourself and you find out. Now, tan 30 is opposite of our adjacent, which is 1 over root 3. You see this? But you know, in surds, you do not leave a surd as the denominator. So you just do what we call rationalize. So if you rationalize, this would give you root 3 over 3. So if you punch this in your calculator, it still gives you the answer, but you leave it like this. Now that is that. Special angle, 30 degrees. Next one, special angle, 60 degrees. Now look at this. From here, sine 60 is square root of 3 over 2. cos 60 is half, and then tan 60 is root 3. Okay, now let me give you a ticket. Let me just give you one giveaway. I call that giveaway. Now my giveaway for this class is this. Did you observe that sine 30 is the same thing as cos 60? Cos 30 is the same as sine 60. You know why it happens? That way, because 30 and 60 are called complementary angles. Complementary angles add up to 90 degrees. Give me another example. 40, 50. Now, what do we know about complementary angles? The sine of one is the cosine of the other. So please take note of that. So that's why sine 30 is cos 60 and cos 30 is sine 60. It's only sine and cos, please. It doesn't apply with the tangent. Now, the next special angle is 45. So sine 45, I'll tell you where we got that from. Sine 45 is 1 over root 2. Okay, and in surd, like I just explained, so we don't have a denominator as a surd, sine 45, so we have 45 degrees here, is 1 over root 2, which is root 2 over 2. Now, can somebody think about what cos 45 would be? Think. You can press pause, think, and then press play. Cos 45 is going to be 1 over root 2. Mr. McCollins, why? I just talked about complementary angles. 45 plus 45 is 90. So the sine of one is the cosine of the other. So sine 45 and cos 45 will give you the same thing, which is 1 over root 2, which is root 2 over 2. Whereas tan 45 equals to 1. How did we get that? Tan 45 equals to 1. Now let me quickly give you, I got that from one triangle, 1, 1, root 2. If this is 45, opposite of adjacent, which is that. So we have sine 30 degrees, 60 degrees, and 45 degrees as the special angles. When I return, I'll give you that of 90 degrees. So we'll take a pause at this point. We shall be back soon.